that mathematical statements not only consist of constants but variables. So I told that I will be talking more about variables. So sorry about this, but we have to incorporate variables if we are trying to say something interesting. Without variables, mathematical statements are rather dull, involving only constants, unless of course we are talking about number theory. We will come across that. So what this part says is that if x is a real number, then x equal to 2 if and only if x square is equal to 4, it's not true. Because you see, when x is equal to 2, when this is true, of course we have this. If x is equal to 2, 2 square is equal to 4. However, if x square is equal to 4, that is not necessarily that does not necessarily tell you that x is equal to 2, because minus 2 square is also equal to 4. So this statement, this is a statement, this is no doubt a legitimate if and only if statement, although it is false. This statement, however, although it's trivial, it's true. It's a true if and only if statement. You can write it like this also. X is equal to 2 if and only if x is equal to 2. So that is if and only if. And you may note this also, two statements x, y are said to be logically equivalent if x is true, if and only if y is true. So this is just a way of saying the same thing, that whenever this happens, we say that x and y are logically equivalent. Okay, these terms are used in mathematics. Now, if and only, okay. Now, so far we have come across 4 constructs, 4 ways of getting new statements out of old ones. So if we are given 2 statements x and y, we know what is their conjunction, x and y. We know about their disjunction, x or y. We know about the negation of x. And we know about their logical equivalence or lack thereof. Now, using only these constructs, there are some laws of mathematical logic that can be spelled out and proved. So let's come to the laws that can be come up with using these 4 constructs. Laws of mathematical logic. Remember, I told you that there is one more construct. That, however, we will come to that somewhat later. So first, let us see what we can do with these things that we have got so far. First, I should mention that, okay, I must say that P and Q are straight. Okay, those things I should say first of all. Let, since we are using x, y, z, let's keep that x, y, z be statements These are general, so they need not be mathematical statements, just statements. Okay, statements which are sentences that are either true or false. Now the first law is law of commutativity. Most of these laws will look rather dull, but some of them which are coming at the end of this list will be somewhat not so obvious. Laws of commutativity, laws, there are two, x and y.